And it gives me great privilege and honor to be bringing you this webinar. You can see a brief overview of background. I started off with a Commodore 64 ZX Spectrum way back in the 1980s, and as I've progressed from the 1990s, from Microsoft MCSC, MCT, Cisco Unix, Microsoft Security, I'm a Master EC Council instructor, developer of the CPTS program and the Advanced 612 Advanced Mobile Hacking and Forensics course for EC Council. Currently, I specialize in radio frequency signals, mobile, AI, robotics, drones, forensics, hacking, defense. Once you've been doing everything, as we've seen the evolution of technology evolve, we really had to keep changing to the different areas of in demand. So as you can see, I've appeared on many different television stations, and I'm obviously a guy that focuses very much on being helpful to others. I'm a Qigong instructor. I've been practicing Aikido for many years as well, and I'm here to help you with knowledge that could be helpful to society. So without further ado, let's jump in to today's agenda. We're going to look at a quick introduction to IoT. We'll discuss AI, artificial intelligence, machine learning introductions, and then I'm going to spend a lot more time covering hands-on demonstrations. We're going to be looking at how we can actually set up, flash the firmware of an ESP8266 IoT chip. We're going to be weaponizing that with a project called D-Author from Space Hun. We'll also be setting up a Mango router, a Wi-Fi attack tool that's going to be converted into a Wi-Fi hacking platform. And then we'll be looking at some more IoT devices from M5 Stack, how we'll be weaponizing those. And then finally, we'll finish off with your cloud setup for Azure. When you need to go and build IoT, you need to set up your initial infrastructure in the cloud. Now, starting off with some crazy news. We've seen this is where the world of artificial intelligence and machine learning and large language models are going crazy, right? So this is towards dog barking decoding, leveraging human speech processing for automated bark classification. This is a university study. You can see all the folks that have been involved from the National Institute of Astrophysics, the University of Michigan, and basically similar to humans, animals make extensive use of verbal and non-verbal forms of communication, including a large range of audio signals. That paper basically addresses the vocalizations and exploration of the use of self-supervised speech representation models that have been pre-trained on human speech to address dog bark classifications. You got to go and read more about it. They will show you that using speech embedding representation significantly improves over simpler classification baselines. And again, you won't truly understand the breadth of this unless you go and research this yourself. But these are just some of the topics of research that I would classify as kind of crazy news, because we wouldn't really be able to predict some of these things if we looked at this 20 years ago. Now, how can we guarantee you're going to be able to build your skills with our AI tactical skills portfolio? We focus very, very in-depthly on hands-on training, giving you a methodology, giving you certainty that if you follow our prescribed methodology, you're going to be able to succeed because you're going to be doing things through repetition. So we actually give you a hardware toolkit, hardware and software, that you get to take home with you. So that way, you're actually going to be building tools that you could then use to do your job. You're going to further build your own mind map, which is essentially a structure of all the components that we're obviously going to be using through our AI tactical skills training programs. We don't have a formal multiple choice quiz or theoretical certification type questions. What you do get is a final day of a practical challenge. So once you've been learning how to do things, you're going to then be given a big challenge that you're going to have to then succeed. So you either build a challenge or you don't. Obviously, you pass and you become certified by actually successfully passing the practical challenge. Now, nowadays, we really need to slip in a little bit of DeepSeek. This is looking at the actual benchmark metrics. So DeepSeek version 3 achieves a significant breakthrough in inference speed over previous models. It tops the leaderboard among open source models and rivals the most advanced closed source models globally. As you can see, the comparisons between DeepSeek version 3 and the other comparisons. I encourage you to go and spend time looking at building your own offline DeepSeek LLM. That way you're obviously going to minimize the kind of data that may be sent to folks you maybe not want to send it to. Some of the new technology. This is a new tiny radar that can detect movements within 1/100th the width of a human hair. It's known as your millimeter wave radar tech, and it's used in this proof of concept device. It's an electromagnetic frequency range that goes from 30 to 300 gigahertz. It's located between microwaves and infrared. It's also used to power high-speed communication networks such as our very popular 5G. It's also widely sought after for its ability to provide long-range sensing capabilities. Now, millimeter wave radars send fast-moving electromagnetic waves to targets to then analyze their movement, position, and the speed from the waves as they bounce back. So this is again where you want to dive a bit deeper into this research paper. The millimeter waves have an array of benefits: natural sensitivity to minute motions and the capacity to focus on tiny scale objects. The future looks very, very promising. Now you may be asking yourself, what is IoT? Let's take a look at this quick animated video.
We are about to wake up to a new world. The world of the Internet of Things. Don't worry. It just means that objects will be able to speak to each other. They'll do our work for us and look after us. Now, isn't that a nice thought? They'll be able to react to our movements. They'll understand when we want some peace and quiet, or when we want to get information and news, or just have a nice breakfast. In fact, the Internet of Things already exists. Many everyday objects are already part of it, some a bit too much. Intelligent objects will improve our interaction with the environment and our work. And as they're intelligent, why not have them do some work on our behalf? So we can concentrate on what we enjoy. Meanwhile, the objects will collect data and take care of us. And that's not all. The Internet of Things will help us save money, do the shopping, avoid lines, all lines. Step by step, the Internet of Things is on its way. We're working on it at this very moment. How about you? Are you ready to wake up to a new world?
So once we taken a dive into that little world of animation as to what IoT may be, remember, Internet of Things really refers to the connection of everyday objects, very small types of electronic objects that allow them to collect, transmit, and share data. So they're therefore networked. This is a very big interconnected network of devices that transforms previously non-intelligent, dumb objects such as toasters or the traditional security cameras into much more smart devices that can actually interact with each other and their actual environment. Now you might be asking yourself, how does IoT work? Well, remember, it's an ecosystem of interrelated devices that are further embedded with all sorts of different types of technologies, sensors, software, network connectivity, and that's all so that they collaborate and exchange data. Now these devices, they are, effectively small objects that communicate with each other over the internet. And they can also further be controlled remotely through the cloud. It works by connecting all these different types of devices through a variety of technologies such as Wi-Fi. And this webinar, we're going to be focusing on how we can build some of these different types of Wi-Fi devices as it's obviously correlating to IoT. So Wi-Fi, Bluetooth, LoRa, cellular networks. Once these devices are connected to the internet, they're obviously able to collaborate, sending and receiving all sorts of types of data that could be better used to track people's health state, monitor their performance, and also control their behavior. This diagram is a look at the world of IoT, and you can see all of different industries, from building and construction to energy to consumer and home electronics, health and life sciences, industrial, transport and logistics, retail shops, security and public safety, and ICT. So this is where we can see a huge array of this technology being used in many different industries. Here's a quick look into IoT in health and life sciences, where we see there's a lot of people globally that just don't take care of themselves. They refuse to exercise. They eat terrible foods that's been processed, that their body doesn't know how to obviously pass through their system, because you're essentially eating plastic, as an example, right? So these types of devices are going to become mission critical to a lot more people that refuse to take better care of themselves. They won't listen to a family member, as an example. They may not even listen to a doctor, but put a sensor in their arm and let them read their vitals. They're going to have more faith in the device that's telling them, hey buddy, you've got this kind, whatever kind of medical issue the person may have. So that's where they're going to be more susceptible to listening to these IoT biomedical type devices. Now I wanted just to throw in, we're going to be running a drone hacking and defense program. This is again a huge popular discussion where everything nowadays is all about robotics, right? And so we're going to help people understand through multiple different level courses. The first level is all about the fundamentals, and again you get to actually take home drones and all sorts of different tools that can be used in developing your AI tactical skills for drone and hacking as well as the defense. Now that brings us nicely into an introduction to artificial intelligence. Remember, AI enables us to better augment our abilities, helping us build amazing software platforms that could potentially be used to improve our healthcare, enable people to overcome physical disadvantages, empower smart infrastructure, create incredible entertainment experiences, as we've been watching with these VR headsets as an example, and even potentially save the planet.
Artificial intelligence isn't coming, it's here. It's the defining technology of our time. But it's human ingenuity that makes it so powerful. Jane started losing her vision when she was 12.
California Street.
She uses Seeing AI,
I crept down the stairs.
I crept down the stairs and out the door,
which enables her to read and navigate her world. Microsoft AI is helping farmers adapt to climate change,
We can use technology to help feed the world without wrecking the planet.
enabling wildlife conservation,
The ability to use AI really democratizes science. WildMe uses images from any source to help study endangered species.
and creating new ways for people with hearing loss to communicate.
I want the exact same information that my hearing friends have.
It's more than just imitating intelligence or sounding like a human. Microsoft AI is changing every industry, from healthcare
And now you can see these finite details, the relationship with many structures.
to engineering and telecommunications.
We are using artificial intelligence to change the way we are relating to customers.
AI lets us put people first.
The Microsoft tools really enabled us to breathe digital life into an iconic brand persona.
The product that we make is not a thing in a box.
No.
Microsoft AI empowers others to create experiences and potential. This is just the beginning.
artificial intelligence, it's just opened up this whole world.
The future we invent is a choice we make.
Now let's discuss next what is artificial intelligence. Simply put, AI is effectively software that's going to allow us to imitate human behaviors and capabilities. The key workloads typically include machine learning, That's normally a foundation for an artificial intelligence system. It's also the way we teach a computer model to better make predictions and then helpfully, get them to draw conclusions from the amount of data they can process. We can throw in computer vision, like in robotics and drones. The computer vision, those capabilities within AI are used to better interpret the world visually through all sorts of different types of cameras, videos, and images. We also have the very popular NLP, or natural language processing. Once again, these are giving you capabilities within the AI technology for a computer to interpret written or spoken languages and then respond in kind. Document intelligence, capabilities that deal with managing, processing, and using a high volume, a lot of data generally found in forms and documents. Knowledge mining, those are the capabilities, again, to extract information from very, very large volumes of very often unstructured data that's going to be used to create a searchable knowledge base or knowledge store. And then very, very popular as well is generative AI. That's basically, again, where we can create original content in a variety of formats, including natural language, image, coding, and more. So we can actually use generative AI to combine all forms to obviously give you the best of all worlds. Next, we want to discuss how machine learning actually works. So how do the machines learn? Well, we use models, learning models, that are going to be used to capture the relationship between the data. Let's take a look at an example here. Suppose an environmental conservation organization wants volunteers to identify and catalog different species of wildflowers using a phone app. The following animation shows how machine learning can be used to enable this scenario. So a team of botanists and scientists collect the data on wildflower samples. The team labels the samples with the correct species. The labeled data is then processed using an algorithm that finds relationships between the features of the samples and the labeled species. The results of the algorithm are encapsulated in a model, and when a new sample or new samples are found by volunteers, the model can identify the correct species and add the labels. Let's talk about another project called Scene AI, a talking camera for the blind. It's effectively a free application that narrates the world around you. It's designed with and for the blind to be used in low vision community. This is an ongoing research project helping to harness the power of AI as well as to open up the visual world. Scene AI assists with daily tasks from reading, describing photos, to identifying products and more. The app continues to evolve as we hear from the community and AI research advances. We want to move on to the IoT device demos. I'm going to be covering 3 pretty deep demos. The first one is going to be compiling source code and flashing a Wi-Fi attack firmware on an ESP8266 IoT chip. We're going to be using Arduino, the developer environment. We'll then also build the customer's Wi-Fi IoT testing tool that really is very similar to Hack5 Pineapple. And we'll also be weaponizing an M5 hardware device. It's an IoT stick, and we'll be showing you what kind of attacks can be done with that type of device. All right, our first demonstration is going to be showing you how to set up a ESP8266 chipset. This is specifically a project called dAuthor. And when we look at AI and we look at the cloud, we need to realize that a lot of these IoT devices need to be flashed with firmware. And then you want to look at how you can connect these to your cloud for your DevOps and so on. Right, so what we're going to be starting off with is making sure you familiarize yourself with this project. So if you go to the dAuthor.com website, I'm using a virtual machine right now using Kali Linux. It's a pretty well-known penetration testing, network security distribution with a lot of tools already built in. It is obviously a lot more flexible when we use Linux. So if you want to go over to the dAuthor.com/docs/about, this will give you a lot more details as to how this project came about. But really what we're looking to do is actually go and set up the software. We're going to be doing this the manual way. We could download a binary file and flash the firmware with a binary file, but we really want to focus on being able to access the source code. So if you want to follow the installation Arduino IDE tutorial, the very first thing we're going to do is go to the arduino.cc website. We need to download Arduino. Now, if you're new to Arduino, you can go and look at a little bit of history from their website. You can see here's a link going through to a YouTube presentation. It's like 15 minutes that was, I think, originally aired on TED Talks. And you can, of course, go and watch a video that gives you more information about Arduino. But effectively, it's an open source electronics platform which is focused on easy to use hardware and software. As you're going to see, you can use all sorts of different IoT chips. It doesn't have to be manufactured by Arduino, and we're going to be looking at an ESP8266 WeMOS D1. We're going to be setting it up on a platform that's only got 4 megabytes of RAM. But as I mentioned, you can go and click on learn more about Arduino. You can look at a little bit more about the history of where it came from, where it's going to, and of course there's a ton of AI. So if you go down to the hardware, you can see there's a huge array of educational kits. You can see the different starter kits that are available, but also going to the cloud and then also going to search for AI. You'll see they got a ton of new AI hardware devices that's going to allow you to take it to the cloud, as well as obviously to set it up for use with artificial intelligence, machine learning, and so on. So take a few minutes and just go and search for AI ML, and you'll see there's a ton of hardware projects, software projects, you name it. But what we want to be doing right now is clicking on the software link. We want to go and download Arduino. So when we go to the software, we want to download the latest version. Right now we're going to be using IDE 2.3.4. IDE is your integrated development environment. And of course, we're going to be using the Linux image. So we're going to go ahead and download this app image, 64-bit. I've already gone ahead and downloaded it. So the first thing we need to do once you've downloaded that file is you need to right click on that file. You need to click on properties, and under the permissions, you need to, very importantly, otherwise it won't run properly, you need to tick the allow this file to run as a program. And so once you've done that, you can then close the permissions and you can actually double click and run this application. In the first few minutes, it's going to take some time to update the drivers depending on if you had Arduino installed before. So this is just going to go ahead and update itself, making sure that it's obviously got all the latest drivers and so forth. So you'll see there it's busy downloading some of the actual packages. Now the next thing we want to do is we want to go ahead and download the actual ESP8266 software, the actual Arduino project file. So you can go down to the dauthor.com website and you can choose to actually, as you can see, download the file and then go ahead and extract it. So there is a link there. If you go ahead and right click, you can see it's going to be in the download section where you can actually download the zip file quite easily. So we'll go ahead and download that. Alrighty, so now that I've downloaded it and I've already extracted it, you'll see the main file we're looking to actually open up in Arduino is going to be, in this case, the ESP8266 dauthor.ino file. So I go over to open up my new sketch. As you can see, I've just set up a new sketch over here. So file new. And now I'm going to go ahead and say file open. So on the file open, navigate to where you've obviously downloaded the source code, and then into the folder, and you'll see there's the actual INO file. So go ahead and open that up. And you'll see how it's going to actually open up a brand new, so even though I had the new sketch open there, it's going to obviously open up a new instance of that. So I can go ahead and actually close my blank new sketch over there. You can see right now this is where it's already got the previous information, so I just changed the board. We'll be showing you how to do that in a second. So if I close that down, and you'll now see, now I have access to all of the source code. But we want to make sure we follow through with these additional steps over here. So if we go back, you'll now need to go into the ESP8266 D-author folder. And obviously this is where we've just finished step 2. And you would need to go ahead on step 3, is actually set up your additional boards. Now I've already gone through and installed the boards, but I'm still going to show you. So if you go down to your actual tools and you look at your actual preferences first. Alright, so you'll see on step 3 you've got to copy that URL there and then go to your file preferences. So if you go to file preferences, you're going to just paste that URL in your additional boards manager. Now this is pretty important because we've got to make sure we use the right board specifically for the project that's being developed with this source code. So once you've selected that, you can then go to your tools and you'll be able to go to your actual board manager. So over here you've got to go, I've already got the WeMOS D1 mini board selected, but if you're just installing this for the first time, you would go to your boards manager, and over here on your boards manager you're going to need to go and search on your ESP, and you should find the D-author come up pretty quickly. So mine's already installed, as you can see, but you would go ahead and you would obviously then click the specific version you wanted, and then you'll click install, right? Obviously on the D-author ESP8266. So once that's installed all the boards, you could then go back to your tools, and under your actual board you would be able to go ahead now and select all the different boards that are available. And of course for us, that's why installing the actual link there, you could tell we've added the new set of boards here, being your D-author ESP8266. And here you've got an array of different boards you can use. Just to give you some insight, if you had to use a very generic cheap board that may need a carrier or a breadboard to hook it up, those are normally with about 1 megabyte of memory. And of course there's various different types of form factor boards that you can actually use. As I mentioned, we're using the WeMOS D1 mini. The reason for that, it allows us to plug it directly in to a USB port. We don't need any breadboards of sort. So if you go back to the dauthor.com website, you can see the link there underneath the DIY tutorial. You can see the supported devices. So this is where, again, you can see this is showing you your Node MCU, which is normally where you could wire this up to a breadboard as well, but it also has a USB connector port there as well, and even a link to where you can go and actually buy them from. This is the board we're using. You can now use a older D port connector or a USB-C connector, but these are about $3 or about 3 to 4 euros, of course depending on where you purchase that from. And you have some additional other boards. So you can see there's a ton of different boards that are available. Now these young guys are even selling some of the custom boards that they actually use. So if you go down to buy, you'll actually see all the various different types of form factors that they have available. So this is where you can see they're all using an ESP8266 chip, but obviously some of them require you to wire them up through the use of a breadboard. Now for more information, you can go down to the version 3. so you can actually see what kind of features are actually supported. We're going to be setting up version 2 as it has a nice web portal that you can actually go ahead and use the web portal to launch all the various different types of tools. And there you can actually see when you actually set this up and you flash the chip, it's got 4 megabytes of RAM. Now do yourself a favor, if you just go ahead, look at the wiki for ESP, this will show you all more in-depth details. But as you'll see, one of the cheaper boards is this one over here, your ESP-01 by AI Thinker. And you can see this has 2 cores, 80 megahertz each. So 2 cores meaning you got a total of 160 megahertz, a CPU, and then your memory, literally it's a total of 1 megabyte looking at this small version over here. Now the version we're using is the WeMOS, as I mentioned, and that actually allows up to 4 megabytes of RAM. So that's giving you quite a lot of additional memory. But as you'll see, this is a chip that's been manufactured by Expressive in Shanghai, China. Alright, so once we've got our board manager set up, we would now be able to, and I've just plugged mine in, so you can see mine's saying that it's actually plugged in, but you need to make sure you go to the actual board manager, select the correct board you're using. As I mentioned, in my case I'm using the WeMOS D1 Mini. It will actually then give you the different ports, so you need to make sure you've got the board port number that it's connected to. So in my case it's using dev TTY USB 0. And so if I just open up the command prompt and I do sudo ls USB, you'll see it's going to tell you this is the generic name of the board. It's a serial converter. And then if you do daemon message as an example, you'll see it's going to tell you the port that it's actually connected to. So pretty standard, straightforward, nothing too complex. You'd also need to set the baud rate. So again, on your tools there, you can see your actual upload speed. In my case, I've got it set to 921,600. Even though I don't select that there are 4 megabytes of RAM available, it will still detect it when we go ahead and flash it in a second there. So just showing you that I've just left it at 1 meg. But you do want to make sure you've gone ahead and changed the erase flash to include all flash contents. So once you've done that, you can see you have access to all of the source code. So if you don't like the way this project works or you want to change anything, you're absolutely able to do it pretty easily. This is why I wanted to show you, rather than just downloading the binary firmware and flashing the device, you don't know what it's doing without looking at the source code. So really important for us is to be able to actually look at the source code. So once I've got this all configured, to actually go ahead and do the flashing, the first thing I would do is I could just choose to verify the source code. As you'll see, it will go ahead and look at compiling the actual sketch, and that will obviously validate that the source code that we've obviously set up is all applicable, and it will actually allow us to flash the firmware on the actual kit, so on the board, as you'll see. So I'm going to cancel that, and I'm going to go straight to the actual arrow where you can see when you hover over that, it will say upload. So I'm going to go ahead and say upload. You can see it's recognized my board over here, and it's actually connected to the actual TTY USB. So if it throws out a few errors, don't worry. This might just be some of the older source code that needs to be fixed, but it should compile. You can see over here it's telling you the details that it's actually connecting. It then found the 4 megabytes of RAM, and it's busy writing the firmware to the actual board. Pretty standard, straightforward. It's not going to take very long at all. Once it's finished, you would then be able to remove the actual newly flashed firmware, re-plug it back in, and you would then be able to actually connect to the actual ESP8266 WeMOS D1 board, as you'll see next. Alright, so now that I've got my ESP8266 board connected, I just plugged it into a battery bank, a power supply, your computer, whatever you prefer. And now I'm going to connect to the Wi-Fi hotspot, as it's called, pwned, P-W-N-E-D. And the password is D-author. So I should be able to connect to the hotspot. Once it's connected, you should see that it is connected. And we can now connect to the 192.168.4.1 is the default IP address that it uses. And you'll see it will give you the disclaimer. So you need to make sure you've selected I have read and understand the notice above. So there you can see it is showing you that it is connected. The first thing you normally do is go ahead and scan for the known access points and stations, the clients that are connected to the different access points. We're not going to show that because we don't want to divulge the other people's neighbors and whatever else MAC addresses. So we've just gone to the actual attack tab, and there you can see your main attacks, your DAuth, beacon, probe. So really this is all we're going to go into. You can read more about what the purposes of this device is. It's really a security device that can be used for both offensive and defensive purposes, allowing you to do reconnaissance through Wi-Fi, and of course taking your version 3 further, where the version 3 doesn't have a graphic user interface. So now we've got to consider what we would do with an IoT device. We need to manage that in the cloud, because what we've gone ahead and set up here is how to do everything manually. But a lot of weaknesses from IoT come from the fact that the firmwares are very outdated and the vendors don't keep those firmwares up to date very often. So this was just one demonstration of showing you how we can set up an IoT device, flash the firmware by using Arduino. We compiled the source code, and obviously we could now take this device and connect it to our cloud as an example. All right, this next demo, we're going to be taking a cheap $30, well, if you get the refurbished version, it's even less than 20 euros. So you're going to be able to use this Mango MLMT 300N version 2 mini smart router. So as you'll see the specs on the actual website, go to gl-inet.com and you'll see all the details about this device. It's got 300 megabits fast Wi-Fi speed, 128 megabytes RAM, 16 megabytes flash ROM, and you've got access to the UART and the GPIO, which is for us hardware enthusiasts that want to create some modifications. So we're going to take this small tiny little device and we're going to build it into a $120 pen testing platform. So if you go to the hack5.org and you click on Wi-Fi pen testing, obviously there's a ton of these IoT chips that are configured to use Bluetooth and Wi-Fi. So there's brilliant projects available where this is going to show you how to set up a Wi-Fi pen testing platform. This is going to be a simulation of the Wi-Fi Pineapple. It was specifically the slightly older version, which was the Wi-Fi Pineapple Tetra version. But nevertheless, you'll see this is where we're going to show you how to actually set up your Wi-Fi Pineapple. You can do a little bit more research as to what the Wi-Fi Pineapple is all about, but essentially it enables us to do Wi-Fi penetration testing with a huge array of tools and modules. You can throw in extra add-ons, and as you'll see, we're going to be turning our cheap little Mango device into that Hack5 Wi-Fi Pineapple. So if you go to their website for their store, there you'll see you can pick one up that's refurbished for $17.99. And obviously it needs to be this specific format. There are an array of other hardware platforms that are supported, so you might never know. You may already have one of these supported devices lying around. So if you want to go over to the actual port Wi-Fi Pineapple Nano Tetra in generic hardware GitHub website. It's called the Wi-Fi Pineapple Cloner, and this will take you through all the different components that you obviously need to have set up. So this is the actual Wi-Fi Pineapple interface that we'll see once we're actually setting up the actual device. Here you can see they're showing you the actual terminal where they actually using a Huawei router 3G. And if you go to the actual list, you'll see the full list of the supported 211 identified devices that can perfectly run the development project over here. And then you can see they made a smaller second repo where you can find the firmwares that you would need to get everything set up. So this will take you through step by step. Now we're not going to go through this entire process. For the most part, it's not very complex. Obviously we want to be able to take you through this in the actual official AI IoT training program. And remember, for us, the way we teach people to build their skills is by giving you a toolkit. So you're going to get an array of these devices in your toolkit that you get to take home with you. So you're not just learning about AI and IoT, you actually building a lot of the actual projects that you can then better understand AI, IoT, and cloud. So one of the other projects could even be using the M5 Stack large language model, and you can see all the great details here about the device. So this is exactly what we're talking about, being able to take some of these IoT devices and use them in the cloud and configure them in the cloud, firmware flash them and all sorts. But at the same time, you're going to be building a prototype solution that you can use to integrate with your AI and machine learning projects. Obviously, LLMs are everywhere nowadays, but they really got a nice little demo that we're going to take a quick look at.
Hello. Hi. It's a nice day today. We should go outside. Hello, my friend. This is the dysfunction. Text to speech. Hello. Hi. Turn on the light. The light is already on. Hello. Hi. Turn off the light. Sure. Hello. Hi. How many days are there in a year? There are 365 days in a common year. However...
Alright, so going back to our Mango router, as we can tell, this is a pretty cheap device if you buy the refurbished version, that we can turn into a professional product that you can use in your IoT penetration testing perhaps, or you can just get some deep insight into engineering devices that can be used in the cloud, and obviously it's an IoT device. So as we saw with the ESP8266D author, we realized that we set up a very, very small Wi-Fi hotspot that could also be used for defensive or offensive purposes. So all the instructions you need are all there in the GitHub page, and obviously we'll be taking a lot more time to dive deeper into these tools that will be part of your actual AI IoT toolkit. Okay, and the last component we're going to need is a Wi-Fi adapter. Now you can get it from Amazon or eBay, but it does need to be your RT5370 version. Now a few pointers: you're going to need to make sure you download obviously the correct firmware. So if we're using the Mango router, you can see this is giving you a form factor. There's the MIPS. If we go further down, we're going to be looking for the GL Mango. So there's the version 2, and you need to make sure you download the 19.7.7 version. So that will go ahead and obviously allow you to download that specific version firmware. And then you've got to go to the firmware-selector.openwrt, and you're going to need to use this firmware as well. So you're going to need to use 2 different firmware files that will be flashing, and you've got to go down to select your actual version here. So there's the 1907, and if you choose the GLNet, you'll find there is the GLMT300N version 2. So those are the main files you need. And of course, as we pointed out, if you go and look at the actual build instructions, the actual install steps, it's relatively straightforward. We're obviously going to be going through this in more detail in the actual AI IoT program, and you'll be able to use it for all sorts of purposes. Now up next, I want to introduce you to M5 Stack. This is another Chinese hardware manufacturer of all sorts of IoT devices. So you're going to see how you're able to go ahead and literally stack and play. So using all sorts of different types of IoT modules. Here you can see this is the ESP32 microcontroller, and you can very easily stack the modules on top, as you'll see when we want to take this IoT device and send it onto the cloud to be managed. It makes it a lot easier because one of the base boards is an Ethernet connector. But as you can see, there's a huge array of various different types of series of boards. We're going to be showing you how easy it is to set up and very powerfully weaponize some of these smaller. This is the M5 stick I'll be demonstrating to you, and also a very smaller version of that device, otherwise known as your Atom S3. So yeah, you can see a whole bunch more information as you see the various different types of capabilities of their devices. I would encourage you to spend a bit of time to go and obviously look at all the different types of solutions they have available. If you go down to the store though, you could see if you click on the actual controllers, you will see some of these controllers have been specifically designed to be used and managed in the cloud. Okay, so here's a great example. And if you click on the core, you will see some of these boards have been specifically designed for the cloud, such as this one here that's specifically designed for AWS. There's also other versions that are designed specific for Microsoft Azure. So yes, these are now hardware devices that we would want to take to the cloud. Now mentioned here is the M5 Stack Stick C. Yeah, it's just using the filters. So I'm going to click on the actual stick and you'll see the various different types of form factors that are available. So I'm going to be setting up this version over here. Pretty cheap device, $22, and you can see it even comes with all the cool functionality. So there's various different types of projects, and you can see there's multiple different tutorials. So you can actually use UI Flow, which will show you how to control the devices through a graphical programming platform, very much like your drag and drop programming, your block scratch programming. very similar to the microbit as well. But of course, you want the flexibility. So if you're just a young school learner, you might be starting off with using block programming. So you can take a look more specifically at the UI flow interface. And it didn't quite take me there though, but yeah, you can spend some time and go and look at that. Obviously, if I click on that, it will then take me to, well, it should have taken us to the UI flow link, but it didn't quite do that. So you can go and check out more of that in a bit, or in your own time. You can also use Arduino. So these are specific tutorials that you can actually go and look at there. Hopefully that takes us to the right link. It still looks like they've got some issues with incorrect links taking us to the wrong place. Or you can use Python. So again, I'm not sure why those tutorial links are not working, but we'll be taking you through some demos. Here you can see the actual link to the correct sites now. So they obviously got some issues with their links there, and you can see that's taking you to the actual flow.m5stack.com, and you can see if you want to use flow 1 or flow 2, it's going to give you a list of different supported devices. And so I'm just going to say confirm, and I'll skip the welcome, and you can see this is what we mean by drag and drop your code. Now if we click on the Arduino, of course, you're going to get given information. It's just going to redirect you to the Arduino website, but you can even use .NET Nano framework as well. So this is just giving you some of the specifications and showing you how to set up your actual driver. So we're going to be using the easy version, which you can basically use the M5 burner. So Easy Loader is a concise and fast program writer. We're going to be using the M5 burner. So if you go further down, you can see some sample code. You can see some of the reviews. And then if you click on the actual software, this is where you can download M5 burner, which is going to allow you to flash the custom firmware. And what's really nice here is obviously it's supporting both Windows, Mac OS, Linux as well. So I'll go ahead and download the Linux version. Alright, so once you've downloaded the actual version that you want to use, in my case I'm using Linux, go ahead and open up the executable. And you can see the first time that runs, it's going to update that for you automatically. And then once you've done that, you can go ahead and restart the app. Alright, so once the app has been restarted, now you can go ahead and you can actually select your different form factors. So this is showing you a small Atom S3 IoT device. Here we're going to use the Stick C. And then underneath your Stick C, you're going to see all sorts of really cool projects. It gives you the factory reset, the demos. There's various different form factors, version 1, version 2. And then you'll obviously select your different board. Now, you'll also be shocked to know that there's a bunch of additional custom projects that very quickly you can actually go and weaponize your IoT device. If you haven't heard of Nemo for M5 Stick, we're going to show you this basic firmware over here. Gives you the ability to use all sorts of nefarious evil stuff, like your TV be gone, shut off TVs, projectors and other devices, Wi-Fi spamming, funny SSIDs, the wonderful Rick Astley Rickroll, Wi-Fi scanning, and then it also has your Nemo portal for Wi-Fi captive portal and password grabber. So there's a bunch of other projects there as well. As you can see, more Marauder for your M5 stick as well. So offensive Wi-Fi and Bluetooth, as well as some of the defensive components as well. So make sure you obviously select the right version, and then to actually flash it would be real simple. All you do is select the different board that you're going to be using. I'm using the actual C+, so I'll go ahead and download that firmware. And once you've downloaded it, all you'll then do is plug in your board with a USB-C connector and then choose to actually flash the firmware. So you click on burn, and obviously this is telling you it's an unsupported firmware. So this is again showing you how we can set up various different types of IoT devices, either manually like we showed you earlier on, or using the specific software that the vendor, the hardware manufacturer, provides you with. The next topic I want to address is Azure Internet of Things. So when we want to go and build IoT devices and we want to add some AI, spices, and machine learning to the mix, we're going to need to use, in this case, we're going to use Azure Cloud. And you can see the different components that are involved in your IoT cloud services. Starting off at the bottom left, you can see your devices. You'll then have a gateway, so you'll be able to collaborate with your cloud-based solutions. So you'll have your different device registries, your device provisioning. You're going to be using an array of service APIs that will allow device updates, managing those devices with additional messaging and processing. So you've got message enrichments as well as your message routing, and then your device management and control layer, all connected to your different cloud services such as your storage, your analysis, your visualization, and your automation, bringing together security, your management, high availability, your disaster recovery, and most importantly, the ability to scale. So scale up or scale down based on your needed demand. So how do we actually set up your IoT cloud infrastructure? Well, many of you who have worked already within the Azure cloud, your prerequisites would be an account. You would need a subscription. You can also use some free trials if you don't have a paid subscription. And you're going to be able to deploy this either through using the actual graphic user interface through a web browser or the Azure CLI, which is normally the most recommended method. And then you'll be looking to include your development environment for your different devices, such as Python, Node.js, and so forth. So you want to then create a resource group, and you can create a resource group as in the slide via Azure CLI. And then if you look at the third step, you need to create your Azure IoT Hub. Again, this example is doing it through the command line interface. The --SKU, your SKU F1, that sets the free tier. Keep in mind the free tiers do have limitations, but obviously very helpful for us in development and testing. Then you'd need to, in step 4, register a device in the IoT Hub that you've just deployed. And you can see this is going through the Azure GUI, the portal. You're going to navigate your IoT Hub in the portal. Under the device management, you will select your devices, click New, enter the device ID, and then if you want to use a symmetric encryption key for authentication, really just recommend it for testing, or you can leave the auto-generated key set to yes, and then click Save. And those are your major steps that are typically involved in getting your initial infrastructure in the cloud for Azure set up. So in summary, you create an Azure account, you need to create a resource group, you need to deploy an IoT Hub underneath the resource group, you need to then register a device identity in the IoT Hub. You can then connect a physical device like a Raspberry Pi, or you can use for testing a simulated device using the various different connection strings. And then you want to send a message to the cloud and optionally monitor them via the command line interface or the UI portal. In step 6, you need to then leverage your device twins perhaps and direct methods to manage the device configuration to allow you to remotely invoke various different types of actions. And then you have the ability to scale your solution using the Azure Device Provisioning Service that could then further integrate with other Azure services as needed. So remember, by following these simple 7 steps, you have a basic but functional setup to manage your IoT devices. The next step would be to look into building your AI machine learning components, all depending on obviously what your capstone project needs to include. And there we have it, folks. So in summary, we really covered the fundamentals of IoT, AI, machine learning, and the cloud, with the array of various different types of demonstrations, showing you how we can actually build and utilize some of those IoT devices. Want to thank all of you for sharing your valuable time with us. Want to thank GOPAS and everyone that has been involved in making these webinars successful, and stay in contact with GOPAS for the next upcoming dates. We are going to be running an array of different types of AI tactical skills training programs for drones, for IoT, for all sorts of cybersecurity technologies. Thanks so much, folks. Wish you all the best for the future. From me, Wayne Burke, over and out.